Hi, everyone. Welcome to today's Tech Talk Live. We are just getting started. A lot of people are joining at this moment, so we'll get going in just a second. I don't like to start too late because I know your time is precious. So for those of you I haven't met before, I'm Kristen Castaldo. I am the Director of Self-Service and Community here at IFS. For those of you who haven't attended a Tech Talk Live before, this is part of our Success Session program. We started doing these about 6-7 months ago, and we do them at least once a month for our customers, partners, and employees to attend. There are several different types. We have lunch and learns, which are quick 30-minute sessions that go over tips and tricks or new resources available to you, product features. We do office hours, which are more of a discussion with leadership at IFS, and this is our Tech Talk Live, which is our longest session, which is a deep dive on a technical issue. For those of you who have attended a session before, you may recognize today's speaker. So Chamaka Wimalarathne, he has presented before. Thank you, Chamaka, for coming back again today. I'll let Chamaka do his own intro, but he's been with IFS for over 7 years now, and he's a lead software engineer. So we're going to keep the questions until the end. You can post them in the chat, or you can post them in the questions section here in the webinar, and I will read them out at the end for everybody. The session is being recorded, so if you have to drop or if things go too fast and you need to come back, you're welcome to watch the recording later and see things again. So thank you for joining us for the Perils of Performance. Chamaka, I'll let you take it from here.
Hi guys, my name is Chamaka Wimalarathne. I'm a lead software engineer in global support and delivery. I have my own fair share of giving performance solutions for customers. People call me a performance fanatic because I love to solve performance related issues. So let's start up. So today for Peril of Performance, we will be talking about 4 different topics. Let's start up with importance of performance. The goal of query performance upgrade is to reduce the system resources required to fulfill a query and ultimately provides a user with the correct set of results faster. In simple terms, if we take it in a nutshell, we can divide it into 2 parts. The first part is what we see inside of the system. From the inside of the system, a higher performance allows the system to run more queries, optimizing its resources, and also reduces the hardware usage, which results on helping servers to run more efficiently. But from the outside perspective, for a user, basically, it makes the application run faster. So basically, that is the importance of performance of software. So I have 2 different techniques talking about today. So its first one is striving in profiling. It's related to profiling mechanism and tracing away the bottlenecks, tracing and TK PROF. So this is the most commonly used one and the most efficient one in my opinion. So let's start up with striving by profiling. First of all, let's check what is profiling. Oracle profiling helps you to assess the quality of data source that you use basically. The source can be a direct query from a table, view, or any data manipulating operation such as insert, update, or a delete. Profiling gathers info from a PLSQL machine level using tools provided by DBMS Profiler package. It enables you to find execution time of a statement, repetition it ran through a system, and even the SQL element that has caused the issue can be found in profiling directly. So basically, that is the idea about profiling. When I usually approach a problem related to performance, I usually use a 4-step theory. The first step is setup, then I check on the execution, then I analyze the data, then I try to optimize the situation. So let's start up from the setup perspective. So if you want to use the IE client for profiling, you need to have several prerequisites. First of all, you need to have IFS app privileges for several permission sets. And there is a small extra step that you need to do as well. You need to go to system parameters. Then you need to search for profiling. Profiling enable is the exact word. What I usually search is for profiling and put a percentage for ease. Then you need to make ensure that profiling enable, profiling allowed is on. After you make it on, you need to go to cache refresh. If it's on, you have to save as well. You need to go to cache refresh and refresh the security cache. So this is the prerequisite that we need if you are going to use the profiler in the IE client. Afterwards, we need to create several tables and tools in order to perform the profiling. We need to have 3 tables basically: PLSQL profiler data, profiler unit, and profiler runs. These tables will be keeping data which is related to performance related query. And if you have a PLSQL developer client, basically you can do this step to get it easily. You need to log into the client, open a test window. There's a gauge mark named create profiler report. It's like a gauge basically. Click on it. After a few moments, you will get a message box asking the profiler tables do not exist, whether it's okay to create them or not. Just click yes. Then it automatically creates the tables that is necessary for profiling. But if you don't have the PLSQL developer, you have to go to the database server, find the file proftab.sql inside this folder location and deploy the file. This file will, after you deploy the file, these tables will be created. So basically you need to do these steps in order to start profiling. Next up, it's the execution. So when it comes to profiling execution, there are several ways to do it. But in general, it's just a 3-step rule. You have to start the profiler, execute the SQL code, then stop the profiler. Just easy. So I have divided this into 4 parts, which is using an IE client. If you have IE client enable profiler option, you can use this. A PLSQL approach. If you are working on a production or an environment that does not have the privilege to start a profiler, you can use this approach if you have PLSQL, and vice versa. If you don't have a PLSQL and you have the issue of turning on the profiler inside the IE client, you can use this approach. And how to use the profiler for Oracle Aurena issues as well. So if we see the IE approach, you need to go to the, first of all, you need to open the debug console, go to the exact window, go to tools, advanced. Okay, it's too fast, you can see. Tools, advanced, then go to profiler server invokes. If you click on this, you will get an extra upgrade to your debug console. There will be a comment box and we will start button. The comment box, we can type the report name which is going to be generated. So when you choose a name, choose wisely so you can easily distinguish a report. Next up, before you execute the process that you are going to measure, click on start. Then try to execute the report, execute the statement basically, or the operation. Okay. Okay. Now we got an error. Okay, this is a classic example of not having the setup properly added. If you haven't created the tables and the prerequisites I mentioned, you will always get this error when you use the IE client. So what we have to do is we have to create the setup and fix it up. for now, I would since I have PLSQL Developer, I would go for PLSQL Developer, log into the database, open a test window, click on the gauge mark. It's create reporter basically, but I call it as a gauge mark for ease. After some time, you will get that box as we saw. It's gonna take some time. Okay. After you get the box, you can click yes, and you can start the profiling process again. So I will be clearing off everything in the debug console first. I have to stop the profiler, the earlier one, give a new name, clear the existing data, start it again, run the same query. If the profiler properly works, you will see green lit statements basically. Green lit statements. So that means the green lit statements are recorded inside the profiler. And by scrolling to the right side of the debug console, you can easily find what is the statement that has taken the most time. Keep this in mind. This will be valuable in the next step as well. Then what you have to do is open a test window in the PLSQL developer, go to the profiler tab. If you have the PLSQL developer, go to the profiler tab. Then you will see the profiler records inside the PLSQL developer. So this is how you gather profiler details using the IE client. This is much easier if you have the access, but if you don't have the access, don't worry, we can use the next step. If you don't have the access, but you have a PLSQL developer, you can go for this approach. Okay. So I don't have the PLSQL access. I have used the same example, but imagine that I don't have the capability of running a profiler, but I have generated the statements. What I can do is select the statement, go to PLSQL details. First I have to find the statement with the most time, then select the statement, go to PLSQL details, copy special, open a test window, not an SQL window. Paste it. I usually beautify everything. If it's not your cup of tea, you don't have to do it. Okay, this is a pro tip. If you are using the copy special, you will always get a semicolon at the end. So if you are using the test window, always remember to remove the semicolon before you run. Okay, get the statement, click on the gauge. Even if you have clicked on the gauge earlier just to create the table, every time if you are using a test window to generate a profiler report, you should always click on it. So if it doesn't matter if you have clicked it earlier, you have to click it always, every time that you use it. Okay, click on the gauge mark. Wait for a moment. Okay, if it's done, it will be like yes. Then you need to click on this cogwheel, the yellow cogwheel. For lower PLSQL version, it's a yellow cogwheel. For higher PLSQL versions, it will be a green play button. So you have to execute it. After some time, you can see the execution process out here, how long it has been taken, how many statements have been generated yet. If it finishes, it shows like this. Then you need to go to this profile. You need to stop the profiler report, go to the profiler tab. Then you will be able to see the profiler report from the first glance. If you use the same test window, definitely when you log into the profiler tab, you will see this one. So same as before, you can use this one, but it will go under a name which is generated by the PLSQL developer. Usually it's the date and the time which it were executed, and you can get the same execution report from here as well. Okay, this is the problem most of the people have. Most of the customers does not have PLSQL developer when they use. So in that kind of a situation, you need to go for a block option. You need to have 3 statements in your test window. You can't, okay. You need to have a declare, a begin and end, as in you are going to create a SQL block. I'm using the PLSQL developer because I have PLSQL developer. If you have a Toad, if you have a SQL developer, you can use the same mechanism. Just have a declare, begin, end. First, you need to start the profiler. DBMS, and this is how you start the profiler. DBMS profiler.start profiler, and add the profiler name. Then you have to add the profiler ending as well. Right here. So if I talk statistically, most of the time, around 60%, the performance are related to select queries. So the problem is, if you are going for a SQL block approach, you can't just paste a select statement like we did in the test window. So we need to create a pro move to fix this issue. So the pro move that I use usually is called as, I call it as cursor for cruising. Basically, I create a cursor with a for loop. I create a cursor and embed the select statement, and I will create a for loop which does not have any return, and I will end it. So basically the for loop will be executing the select statement. So we can record the select statement's behavior by using this mechanism. You can't just put it out here. Copy it, go to declare, paste it, create a cursor. Yes, put a semicolon at the end since it's a cursor. Put the for loop out here. Then same as before, you can execute this block. After you execute the block, you can get the profiler done. So this is how you create or execute the profiler for IE clients or any SQL statement. The only difference that happens in Aurena is just finding the SQL query which is related to the performance. That is the only difference. So what you can do is, what I do is, I don't usually go for the both tools inside the IFS. I go for the developer tool inside the browser. Basically, go to the network tab. Then I go for the debug console just to get the statement, but I do the measuring from the network tab of the developer tool. So I get the debug console just to get the SQL statement, clear it out. Then I'm going to clear out this one as well. Perfect. Then what I'm going to do is I'm going to execute my statement. I'm going to click on my level details. So let's see what is the time crunch out here. To figure out the time cruncher, I'm using the network tab of the developer tool. It distinguishingly shows you the times, and it's easier to find what is the query related. Is it this one? Nope, it's not this. It's this one. Okay, so what we need to do is we need to find this exact statement inside our debug console. It's easier to find a debug console because of this reason. You will see now. Okay, this one or this one. Okay, it's this one, right? No. Okay, let's see again. Now say a structure. Okay, it's this one. Okay, after selecting the statement, okay, it's perfectly fine. Okay, let's go. Now go to the SQL tab, copy the whole thing. This is how you distinguishingly find the select statement related to the performance issue inside Aurena. After that, you can use either the PLSQL mechanism or the generic mechanism that I showed you using the blocks by just taking the select statement. So that is how we collect performance related, we execute and collect data for performance related issues in Aurena. The only harder part is the the process of selecting it, basically selecting the select process. Select. Okay. Okay, let's talk about analyzing it. When we talk about analyzing it, it's a race between three tables, basically. PLSQL profiler runs, PLSQL profiler data, and PLSQL profiler units. These tables are interconnected using these keys. So remember, we need, if we don't have a proper tool to get the data as we did in PLSQL Developer, we need to generate a query which embeds all these logics. Basically, you need to have a join between these two, you need to have a join between these two, and you need to have a join between these two, basically. So let's see. So this is how you see in the PLSQL Developer, as I showed you earlier. It's easier. You can go for the test window, go for the profile tab. By using this option, you can just sort it out to get the maximum time. But when it comes to other developer tools, basically Toad, PLSQL Developer and such, you can use this query. I will send you guys this query. This query is designed based on the logic that I showed you earlier. You need to have connection between run IDs, unit numbers, again run IDs. I have empasses this to get just to remove the zeros, because we don't need the zeros. And the run comment is necessary to identify the exact profiler report, and it has been divided by this amount just to get it from seconds. So this is the query that is necessary to get a profiler report in any developer. So this was the problem for most of the developers I have faced, basically. So this is the remedy for the issue that you have now. I will pass this on. Okay, now since after you can sort it out from here, and find out what is the point which is related to performance issue. Especially it shows the unit, which is the API, and the line number of the API, and the exact line. If you use the PLSQL developer, you can find the unit, the line number as here as well. We can go for more details, but as you know, if we increase the amount of columns that we are going to populate, the more it will uh, decrease the performance of the query that we use to measure the performance. So basically these are the most needed ones. That is why I have listed these ones. Okay, let's go back. So the next step is optimize. Rather than talking about optimizing now, I will be talking the optimizing after I talk about the next what we call the tracing away technique. Okay, next up, the technique is tracing and TK-PROF. I call it as tracing away with the bottlenecks. So what is SQL tracing? SQL trace facility and TK-PROF lets you accurately assess the efficiency of a SQL statement. And the SQL trace facility also provides you to collect performance details such as execute and fetch counts, CPU elapsed times, physical reads, logical reads. It's more content heavy when it comes to comparative to the profiler. We can get more information and more important information if we are going for a more complex issue, basically. But for my preference, I usually go for profiling rather than SQL tracing or the PROF, because of a certain reason I will explain you later. So since we don't have much time, I'm going to do the setup and execution in the same video. So as we did earlier, go to system parameters. You need to search for trace. After that, you will get this statement, long statement, SQL tracing allowed should be off for production. As you can see, it's not recommended for production. So you need to turn it on, save it. Again, the same process, go to the cache refresh mechanism, refresh cache out there. The security cache is the most important cache when it comes to this kind of stuff. Then switch off, restart the application. Earlier I did the restart, I had to minimize the video because we don't have time. If every time you refresh a cache, always remember to restart the application. It's just a tip, not a pro tip even. Okay, again log into the application, same process, go to the window which is causing the issue. Then you need to get the debug console as before. Debug console, go to tools, advanced. This time we are going for SQL trace. Again, we are going to get several upgrades out here. So we are getting a client ID, a trace directory. Trace directory shows where the location of the file that gets recorded. In this approach, rather than saving the data into the database, it will generate a file with the data that we are going to collect. So this will show the location of the file that is going to have the data which is related to the performance issue. And there will be a start button as well. So before you execute the statement, you should start it out. You don't have to define a place because it's get automatically defined. Click on start. Again, green lit. That means it's starting to record. Run the statement. Every statement will be here, then stop it. That's all. Then what you have to do is you need to remember the start time in the debug console. You need to get this location and send it to the database admin. Database admin has the access to the database server basically, and it's inside the server. And he will send the file which is generated at this moment at this file directory. The reason I don't like this, I don't prefer this method because I have to rely on another person and it might take a lag of time. As in, we have to send the location, we have to send a time, and we have to wait until the database admin fetches the file and send it to us. If you are going for a profile, a mechanism, we don't have to wait for anything. We can just cruise with our performance issue. Okay, that is the reason I usually prefer PLSQL profiling to tracing. It's your cup of tea. You can select anyone you want. I just want to point this out. Okay, that's all. So after you generate the profile, the SQL TK profile, you need to analyze it. So a well generated file, a log file, will be shown as this. The file will include text of SQL statements. The SQL trace details will be in tabular form, and there will be information related to the execution plan. These are more extra information, and you will get these kind of information as well: number of times it was executed, CPU times in seconds, elapsed times in executed, a lot of information about the situation. But when you get a file from the database admin, it won't be showing us this. You need to do a conversion of the file to get this format basically. So let's see how we get that. We need to go to the location of the file which we got from as in the location we have copied the file in our machine. We need to press shift then RMB and open a command prompt out here. Then it's a PowerShell for me. Then I'm going to copy the whole name of the file. Then I have to write, you have to have Oracle in your machine in order to do this. I type tk prof, paste the name dot trc, which is the format of the file. The file format we are going to export is log. So we are going to put the same, in order to distinguish it easily, we are going to put log for the same file name. So once you execute this statement, you will be getting a text file. The text file will be similar to this one. So that is one approach. But there's an easier way if you have a SQL developer tool, not PLSQL developer, and SQL developer. If you have SQL developer, you just have to open the TRC file using the SQL developer. Go to the file location, open the file. That's all. You open the TRC file from SQL developer, it will be shown in tabular form automatically. You can see tree view, statistic view, list views. List views, you can generate more information. The these information will be in the text view as well, but this is more easy to create rather than going for an Oracle situation. You can get it from here. You can do this by using SQL Developer. I have only tested it with SQL Developer. I haven't tested with other clients, so I'm not sure whether it can be possible, but definitely SQL Developer can do this. It's easier to find here, see? Okay. So now we know how to analyze from PLSQL Developer, so from TK Prof, as well as from profiling. So now let's talk about increasing the performance of these situations by optimizing it. So rather than talking about losing performance, let's take a positive gain. Let's see how to gain performance in 10 ways. Okay, first of all, keep statistics up to date. Database stats, I call it stats easier, helps SQL statements to find its optimal path of execution. If it's using out data stats with older data stat, basically, it won't find the proper optimal plan for execution, will result on performance issues. In simple terms, the main purpose of this method is to find the proper index for the proper solution. Okay. Since Oracle 11G, stat update are gathered automatically by default. There are two schedulers automatically that does it. One is called as weeknight window, which start at 10 p.m. The server time, database server time, and ends at 6 a.m. The other one is weekend window, which covers the whole Saturday and Sunday for this operation. But if you want to gather the stats basically quickly, you can use these operations. If you are using an SQL client, you can use this. You can execute this mechanism, this method, dbms stat gathers. It will gather all the statistic related tables. And before doing this, if you want to check whether the stats have been gathered earlier, as in on a near date, you can use this query. This query for tables, all tables, this query for indexes to find out what is the last date or the last time the stats were gathered. If it's on a recent date, you don't have to gather stats. If it's on an older date, you can do it by here. If you have IE client or even the cloud client, you can gather stats automatically by using this database schedule. You have to go to new database tasks, search for this one, and you can execute it as you want, as in you can execute it now, or you can perform it as a schedule. You can do it by using this one. Okay, that's how we keep stats. Okay, next up is the big boss fight between in and exist. The in operator is used to retrieve results when the specified value matches any value set inside or returned by a subquery, basically. This operator allows us to simply to specify multiple values along with the where clause. It reduces the usage of multiple or conditions in select, insert, updates, and deletes, basically. Rather than using or conditions, we can use in statements to reduce it, basically. So we call it also as the shorthand of multiple or conditions. So if we talk about exist is a Boolean operator which checks the subquery's result and returns either true or false. It uses the combination of with the subquery and check whether the row is returned through the subquery or not. If this operator returns true, the subquery at least has a single record inside the where clause, subquery as in here. If it does not have any records, it will return false. So basically, this is the structure, simple structure of an inquiry. You can put a subquery out here. This is for exist. There are reasons for using exist or in depending on the situation. So let's compare and contrast both. For in operator, we use it for minimizing or conditions. Exist operator used to check the existence of data in a subquery. In operator compares the values between a child query, the inside query, and the parent query, which is going to refer the child query. in exist, it does not compare the values of the query. It just checks the existence. It does not compare values. That's the difference. In block, it will scan all the values inside the in block. But in exist, this is the game changer. In exist, it stops once it finds a positive conditions that gives the true as the output basically. So basically this will stop once it finds a result. Even this will scan the whole thing. So that is the importance of exist when it comes to searching for existence of record basically. But the problem is in operator can return true, false or null, but exist operator cannot return null. It will just return false. So if you need to compare with true, false and null, exist operator is not the one to go. For in operator, we can use it on subqueries as well as with values. You can put values inside the in as well, but there's no point of using values inside exist. So it's only for subqueries. The purpose is for subqueries. If the subquery results are small, in operator is faster than exist. If the subquery result is larger and you need just to see the existence of record, exist operator provides better performance compared to the in operator. Okay, now you can select in or exist. Okay, the next fight is between join and subquery. A join is a query that combines records from two or more tables. A join will be formed in the from place of a select statement basically. A subquery or an inner query or nested query, we call it as nested as well, is a query within a SQL query and embedded within the where clause. A subquery is a select statement that is embedded in a clause of another SQL query, in other words. So they can be useful to select rows, tables, and conditions. So rather than going against it, let's check the advantages and disadvantages of these two. The advantages of using join is you can maximize the calculation burden of a date. You can maximize the calculation burden of the database instead of using multiple queries. Gives additional burden. You can use a join and make it low. But the disadvantage of join is join includes using of join includes that they are not easy to read as subqueries. If you are using the join in a select statement, the logic seems to be a bit of complex and it is hard to read. So it is hard to maintain compared to the subquery, because in subqueries, what we do is we have divided the logic into several small parts. But in a join, we have combined all those logics into a single statement, which is harder to check and maintain later. Okay, subqueries. The advantage of subqueries, as I said before, it has been complex queries have been divided into parts with logical steps and easy to understand and easy to maintain. But in many cases, a statement that uses a subquery can execute it more efficiently if we write it as a join. So join is more faster but hard to maintain because the logic seems to be complex. So if you're going for complex logic and you are not very considerate of the performance at the moment, the best option is subquery. But if you are willing to have more performance, join is the best option. Okay, select all is always bad. This is a statement that we can make, because if you select all, we get all the unnecessary data than we required in the client basically. So if we are trying to get unnecessary data, it will use more network bandwidth than we design the query for. The increase of the network bandwidth will result on performance degrade of the data when the data reaches from database to client application. So basically, select all is a bad idea when it comes to selecting options. You should always go and find the explicit columns that you need to find, and using the explicit columns is also easy for the future as well, because it's easy to maintain. It creates a maintainable code basically. So I don't prefer using select all always, but if there's a necessary need to use select all, you can use select all, or else the best option is to use the explicit situation. So number five is selecting the best data type and size. This is a place most of the time the developers messes up when they focus on the logic more than the performance, because developers tend to use variables, just tend to, not all or everyone, tend to use data types that comes to your head. If they want to get some text, rather than using vacha, they can use long because they can use blob because it's easier, has more access for it. But the problem is every data size that you use allocates a percentage of the database to at least to store the variable as well. So it uses more space than the other one. For an example, if you all we have to always use tiny int instead of small int or big int, if we are going to store positive integers between 0 and 255, because tiny int only takes 1 byte, where small int takes 2 bytes, int takes 4 bytes, and big int takes 8 bytes. This is an example. And when you use text data types, you need to use it when you want to store large amount of data. If you don't have a large amount of data, you can change the data accordingly. And this is the biggest one. Please avoid using encha and vacha instead of cha and vacha, because encha and vacha uses double the size as cha and vacha. This is a common mistake that developers do. So you have to be really selective in database size and type if you want to have better performance. These might be seem to be little small things, but these are the things that can increase the performance well. The next step is using indexes in an efficient manner. Indexes are super crazy when it comes to select statements, I know. But if you increase the amount of indexes, it will result on decrease of performance in input-output queries, basically, insert, updates, and deletes. So you have to have a clear idea about having how many indexes do I have to have. You can't measure it. There's no borderline saying you have to have 5, 6. It can differ according to the number of inputs and outputs that you do to that table, basically. So you need to assess the speed of insert and update when you always decide on using an index. And this is just a tip. If you are using IFS application search, if you go to the advanced tab, if a column is indexed, you can see it from this green arrow. So if you want to search something quickly inside the IFS application, always try to target these kind of columns, the ones with the green arrow. Okay. Next up, it's trying to minimize the leading wildcards. Okay, rather than explaining it, I'll just show you from the select statements. There are 3 select statements. I want to check the marital status as married for several people. So what I'm going to do is I'm going to write it on 3 ways. One, just have the wildcard. The other one has married and wildcards in the side, and just married out here. If we take performance of these 3 select statements, this one has the best performance and this one has the least performance. So using the wildcard, we usually go for unnecessary searches. So it's better if you can minimize the number of wildcards that you use if you are directing a select statement in a code, basically. I usually don't prefer using wildcards because we need to get the exact amount. But if there's a need, you should always be careful of the performance as well. Okay, next up is a jiffer. It's between bulk collector and cursor for loop mechanism. Cursor for loop. Okay, bulk collector is one of the way of fetching data in bulks. With Oracle bulk collector, the PLSQL engine tells the SQL engine to collect many rows at once and place them into a collection. Then afterwards, we can use that collection to gather the data. But if you're expecting just to retrieve small amount of rows, the best option is going for a cursor for loop, because then the performance for cursor for loop is more likely to meet your requirements. The larger the number of rows you would like to collect, the bulk collector is the best option. Uh, if you are going to have as I said before, a small number of rows, small number of records, the best option is the cursor for loop. This is how you define a bulk collector. You have to write the statement like this. It's a select statement, and you have to use the collector inside here. And this is for cursor for loop. You have to write the cursor and the for loop out here. So between these two, if the data set is larger, this one is better. If the data set is lower, this one is better. Okay, let's go for the ninth one. It's a small fight between exist and count. Okay, this is a common issue with most of the developers. Exist always almost faster than count, because count goes through the whole cycle, but exist stop when it finds a situation. I have seen so many developers code in a certain way just to get a count and assign it to a variable, then check the variable inside a if loop and check whether there's a value greater than 0, and if there's value greater than 0, they will use that if conditions to work their operations. For those people, I have to say is just use the exist option. You don't have to write those whole 3 statements and kill off performance of a system. You just need to have the exist statement written for those situations. Okay, last but not least, okay, this is a biggie. Avoiding PLSQL calls in where clauses. If you talk about where clauses, PLSQL functions, there can be multiple executions. If we have where PLSQL calls inside where clauses, there can be switching of SQL to PLSQL context, and this leads up to inefficiency, because functions may prevent using the perfect indexes. Also, the functions may run slowly, as I explained earlier. So basically, it's better if you can avoid PLSQL calls in where clause as well. So these are some 10 small tips that can use to optimize performance and increase your performance of the system basically. So that's it. Time for questions and answers now.
Awesome, Chamaka, thank you. That was that was a lot, but very, very well done. So if you guys have questions, please go ahead and post them in the questions section, or also in the chat section. I'm looking out. We haven't had any come in during the presentation as far as explaining what you covered. And we did record this session, so again, if there's anything you missed or anything you want to watch again, we will be sharing that on the community. We can also share the slides on the community as well.
Just because I change
one.
the slides, you don't have to stop asking questions. If you have questions, you can go. Yeah.
Gotcha. So there is one question that just came in. We have, what effects on performance when the profiler is enabled, i.e. when the 3 profiler related tables have been created?
Okay, if you have created the tables, if you are using the tables, and if the tables are filled up, it's gonna affect the performance as well. So in that case, you have to clear out the tables. There are statements for that as well. What I usually do is, if I create a performance table, I didn't write those queries. If I create a performance tables, after I do my profiling, I usually delete those tables again, because there's no point of keeping it. If you want to keep the data, you can always RMB on the profile tab, and so not the profile tab, in the test window, and get an export of comma separate values. The best of, yeah, I haven't written that. If you want, I can comment it on the post that is going to be posted. You can delete the data and you can delete the table as well. It's better to do it in a production. If you have done a profile in production, I usually don't do profiles in production. If you are going to do it, always remember to delete the tables. And it's only if you have created tables. For an example, if you haven't created the profiler table, someone else might be using it, so don't delete it at that moment. If you have created the performance related tables, do the performance related query, then delete it afterwards. That's the thing I have to say.
Great, thank you. Another one. Will you give an example of how to write the exist instead of account?
Uh,
Is that one we can do on here? Is that something we might need to take to the community?
I'll post it on community. It's a small thing. If you write a count, as I explained you, if you write a count, you will get a number. It's not a number. You're getting a number basically, right? Then you are going to compare the number. Uh, then after you compare the number, you will check whether there's a value or not. Afterwards, you are going to use the statement that you are going to use it. And if you use the exist, you don't have to use it. I'll say I'll put a query. I have to type it with this current situation. I can't do that. I'll do it. But the problem is there are reasons to have these kind of situations, even though it is a performance killer, right? There are places where you have to use the count, even if there's exist. So basically, if you have to use the count, you have to use the count. But there are places I have seen where unnecessary to use the count, and it can be replaced by exist. That is what I explained. I will put a descriptive post about it in the IFS community after this presentation basically. Yeah.
We have a couple more. Which is the best way to set up integrations with third parties, web services, ODBC, or direct DB connection?
Basically, I have only covered the PLSQL developer related performance issues, so I haven't. Uh, uh, I have an idea about those situations, but if you want to get an answer about that question, it's better if you can raise it on community basically, because
Okay,
this is related to the client and the database, not any integrations.
fair enough. Okay. Is it possible to identify indexes in an Arena search?
I haven't tried that, don't want to lie.
Okay,
Uh, but since if you are using Arena, if you that means you're not using the cloud, that means you are using Arena, that means you have IE client, so you can find it out there. Or else you can find the index by using your database uh, client. You can open the table out here, RMB on it, edit the table. On the second tab, there will be indexes. That's easier. Don't always go think as in I have Arena, I have IE. If you want to find an index, always the best option is to go for the SQL developer client. Uh, if you're referring it to this Arena search, I haven't used it. I haven't seen it, an advanced option out there. So it's not possible. As I know, it's not possible, but it can be. I'll check it out and post it on the community as well.
okay, perfect, thank you. We may have time for one or two more. Regarding one of the last points, we often use function calls within where statement and custom fields. Should we aim to replace all function calls with join statements to improve performance?
If possible, it's better, because join statements are better in performance. As I said before, if you have function calls, it will have a switch between SQL statements and PLSQL functions. So that switch is a performance killer. It's about how you design and you develop. It doesn't matter if it's faster if you are using a join, but it's better if you can design it accordingly. It depends on the design, but I would prefer if you don't use function calls, and if you can use joins instead of function calls, it's a win basically. But there are instances that where you can't do that.
Okay. Which profile or options methods are available for IFS cloud-hosted customers? Specific to
Uh,
apps 10 was the question.
Abstain, the IE option is available. PLSQL client will be hosted by our cloud team, so PLSQL is option. Every option is available for cloud customers if it's applications 10. But if you go for a cloud customers, not applications 10, I think it's all because it's all Arena. You have to use either one, two, three, or four. As in you don't have IE. But when it comes to applications 10 and services, managed services, you can use all four options. But if you have cloud, you have to go for 2, 3, and 4. You don't have IE.
Okay. Okay. I think we've got them all. Oh, hang on, there's one. Someone says, what kind of joins? Inner joins or joins with plus logic?
It depends. It depends on the situation. It's like how you cook, right? You it might be hot, it might be cold. It depends on the dish, right? So it's like that. The join depends on the situation and the code that you write. I can't just comment without seeing the code.
Gotcha. Okay, well, what we'll do is we'll put up the recording on the community. We'll put the slides up on the community if that's fine. And then you guys, if you have additional questions, you can post in that space. Thank you everybody for attending today. We are doing this again on January 28th. We're focusing on Arena lobbies in IFS Cloud. So we hope you can join us for that one. We also have a post in the community if you'd like to provide any feedback about what other topics you'd like to see covered in these sessions. We're happy to hear that. And again, Chamaka, thank you so much for this presentation.
Thank you,
Hope to see
Kristen.
you
Thank
guys
you
at the
all.
next one. Bye all.